The next one we consider as the mid-square method. In this method, the hash function h of key k is obtained by selecting an appropriate number of digits from the middle of the square of the key k. That means the key is squared first, and out of that square we will be selecting only the fixed number of digits. Here as an example, k is given by 486 and h of k is equal to h of 486, and we first square the digits or the number. We get 236196 as the digit. From right side we will be selecting only the digits that are present in even position. That's why it is given select even positioned digits. So 9 is selected, 6 is selected and 2 is selected. Since it is available from right to left, second position, fourth position and sixth position, and write the number from left to right, so that the number is 269. So 269 key 486, therefore for key 486 is placed in 269th index of the hash table. This is called mid-square method. The next one is the division method. This is one of the most fastest and most widely used hash function out of all the different hashing methods. In this method, the hash function h of key k is obtained or defined by h of k is equal to k percentile d, where k modulo division d. We say k is the key value, d is the length or size of the hash table, or sometimes some people will write it as n, where n represents the size of the array. The ideal choice for the size of the array is a prime number, because the prime number has only two factors, 1 and itself, so we don't get any duplicate values or the duplicate locations for storing the data values. Now let us consider k is equal to 486 and d equal to 5, where 5 is a prime number. When we divide 486 by 5, we get the remainder as 1. That means the key 486 is stored in first index of the hash table. This is most widely used and mostly acceptable kind of division method. The last one is the oldest method called digit sum method. It is the simplest method in which the sum of the individual digits is calculated for every key. For every key, we will be calculating the sum of the digits. From this sum, the position of the key value is obtained as the digit at units place. Whatever the digit present at units place is only considered for storing the respective data item. Let us consider k is equal to 486. H of k is given by h of 486, where we sum the digits. 4 plus 8 plus 6 will give 18. So at units place 8 is available, so at 8th index we store 486 by ignoring 1. However, all these methods lead to a serious problem of collision. Collision means when two or more number of data items are mapped to the same index of the hash table, then we say that a situation has arrived called collision. This collision has to be resolved by using some of the collision resolution techniques. So the collisions must be resolved using collision resolution techniques such as open hashing methods and closed hashing methods. These techniques we have already discussed in the 4th unit, so I'm not discussing those concepts right now. Now we move on to the one more important file organization technique called indexed sequential file organization. Indexed sequential file organization is the combination of sequential and direct file organizations and is suitable for those applications in which the records should be accessed both directly and sequentially. That means in some situations we may need to access the data records one by one, starting from the beginning to the end, and in some situations we may be accessing the data record directly. That is, one particular record is only required, which is not possible in sequential storage location. And in direct file access, we will be accessing only one particular data item, and it is not possible to access the data one by one. Now, in general, when we apply sequential file organization, performance characteristics is very low since it accesses the records in sequential order, that is one by one. To improve its performance, a slight modification is added called indexed sequential file organization. An indexed sequential file organization is a type of file organization in which we will be applying the indexing. Indexing means ordering of data items. We will be applying indexing on one of the data items present in the record, and that data item is generally non-repeating, non-redundant data item. That means not duplicating item. So unique values are only accepted into that particular data item of that record. Now, if that record contains only unique values, now you can maintain ordering. Ordering means arrangement of data in a particular order. So indexing is done on such particular type of data item so that we can access the data item very quickly. In this technique, the performance can be improved by placing or arranging information in an order and put tabs or an index at some particular points to group the values. That means the data values are stored in an array format and the data records are represented along with some groups, like the groups represent the values less than or equal to some particular value and the values greater than or equal to one value and less than or equal to some other value. For example, the records are stored in such a manner that the data items in a particular field are stored in such a manner with the indexing concept called all the values that are less than 100 are placed in one group. The values lie between 100 and 200 are placed in one group. The values greater than 200 and less than or equal to 300 are placed in another value or another group, and so on. Such kind of grouping concept is applicable in indexed sequential file organization. In this technique, the performance can be improved by placing or arranging the information in an order and put tabs. So we have discussed this. The search the record with index until we find the group that contain the desired record is present. So we will be applying a searching process on these indexes, and we apply this searching process to find the group in which we require our required data item is present. So it reduces the number of comparisons when compared with normal sequential organization. Still, to improve the performance, next higher level indexes can also be defined. This I would like to explain with a simple example. Consider the given file of records as 11, 23, 55, 86, 125, 157, 178, 200, 230 and 280. These are stored in an order. For this, set the index value as like this. At 23, between 23 and 50, I have set an index value, lower level index value as 50. That means that the values to the left of that 50 are less than 50. Next, between 86 and 125, I have placed one index called 100, which will represent that all the values to the left of it are less than 100 and to the right of it are greater than 100. Similarly, between 125 and 157, I have placed one lower level index called 150, whose less than this 150 values are present in the left left list, and all the values to the greater than 150 are placed on the right sublist. Similarly, 200 and 250. And one more higher level index is placed at 100 and 200. So 100 is here, meaning that all the values to the left of 100 are less than or equal to 100. All the values between 100 and 200 are between 100 and 200, and above 200 are placed on the right side of 200. This is something looks like a skip list. Here we will be first applying a search on the upper level or higher level index. Here, suppose that I want to find the location of the element whose data item or the key contains a value called 150. So first we will be applying a search on this higher level. So 150 is greater than 100. So we skip this left side sublist and we will be moving on to this case. So it is greater than 100, but still we have 200. So if 150 is less than 200, we will be using only this group of data items to find our required data item, thereby skipping this list and this list. So this kind of data structure we also consider as a skip list. So here 100 and 200 are higher level indexes, and 50, 100, 150, 200 and 250 are low level indexes. Now to locate a particular record, first search record key value compared with high level index value. If the values is less than or equal to specific index value, then search process moves to its left side, otherwise to its right side. Now it is compared with low index value and the same procedure is applied. Based on the comparison, the control finally moves to one particular set of records and then search proceeds with sequential search. If key is found, it refers to successful, otherwise unsuccessful. Let us assume that I want to find the location where 86 is present. So first we apply the search operation with higher level index. 86 less than or equal to 100. Here the condition is true. So the rest of this particular groups is ignored. Now moving on to the second level index or lower level index. Here we apply again 80 between these two. 50 greater than 80 lies between 50 and 100. If this condition is true, then we check here, otherwise we move to the left side and here. So 80 is compared with 50 first, 80 greater than 50, so it moves to this side, and 80 less than or equal to 100 is true, and here also we will be checking. Once we reach to the respective group, here we apply the sequential search. 55 equal to 80, 55 equal to 80 is false. 86, so move to the next position. 86 equal to 80 false. So there are only two data items present. Since 80 is not present, we conclude that the search is unsuccessful. Similarly, let us assume that I want to find the location where 230 is present. 230. First we apply here 100 with 100. 230 is less than or equal to 100 is false. Next we apply 230 greater than 100 is true. So the condition checking moves to the second level, the higher level again. 230 is greater than 200 is true. So we move to the right side. In the lower level, we again verify 230 lies between 200 and 250. So we apply the sequential search with the respective data item present in this group. So 230 equal to 230 condition is true. So we find the location where 230 is present. Here indexes are used and sequential search is used in both cases. That's why this is called indexed sequential accessing technique. So this is the end of our sequential direct access and indexed sequential techniques. Thank you.